Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm Steve Marks.
Well, what do we got this week, Steve?
We have a gold mine of a show this week. We have, of course, we will cover the news. We've got a feature that is about what happens after you've got your application up and running in the cloud. How do you roll out updates to your service? What are your various options? What things do you have to keep in mind? So some sort of, we'll discuss that. Some of the different options. And then we'll wrap up with a tip of the week that relates to that a bit. It's sort of a gotcha around doing upgrades and ASP.NET encryption, like around session state, things like that. So that's a little bit of a teaser for that. But stick around for that. I wonder if people don't. Like if there are a bunch of people who are like, oh, it's time for the tip of the week. They watch the hilarious thing we do, and then they just turn it off. So that's why we need to set it up. Like, no, it's going to be really cool and important.
Right.
Don't turn that dial. I don't know what the internet equivalent of that is. Don't click over to the other tab.
Don't alt-tab us, please.
Don't alt-tab us out of there.
Okay. Well,
anyway,
let's cover the news, and
let's at least
we'll
start
try.
with the news.
We'll try to get to the interesting stuff.
We'll do our
here.
best.
All right. So first up, we found that the Windows Azure Architecture Guidance Part 2 has released. They're developing applications for the cloud code samples. This is the Tailspin surveys. So this was a sample written explicitly for the cloud, so it took some design considerations of using table storage, of using blob storage, kind of a greenfield scenario.
So this is as opposed to, so the part one was migration,
yeah.
Right? So this is the, and we definitely talked about it several times, I think, that the patterns and practices guys were putting together. Eugenio was putting together.
Pache.
Pache, sorry. Yeah, I left off the best part. Was putting together this stuff with the rest of his team, but was putting together the stuff about migrating applications to the cloud. Now they're on to part 2, which is new applications.
I think we're
done
with part 2. This is just the samples have actually been
These are the samples.
published.
Well, where's part 3 then?
I think that's in the can, or going to be done, or something to that effect.
Really?
Yeah.
Wow. Is there a part 4?
I'm assuming.
How high does it go?
I'm assuming there's at least 10 parts.
At least 10.
Yeah. Well, how many parts did Rocky have? We got to at least beat Rocky.
Ugh.
There's 6, right? 6.
Yeah,
or
but
7?
they don't use Roman numerals here, so I don't think it follows the same rules.
Does Rocky use Roman numerals?
Yeah. It's Rocky V.
Oh, yeah. Good point.
Right? Okay, anyway, so these code samples go along with all that stuff, and they're cool, presumably?
It's great stuff.
Okay.
I've seen it before. It's good stuff. I like what the team did. All right, so the next item up is from Roger Doherty, who is the SQL Server evangelist. Great guy. He actually lives in Philadelphia.
Really?
Yeah.
I didn't know that.
Yeah, he's an Eagles fan. We'll forgive him this one time.
Yeah.
But he has an article on, or a blog post. I say article. It's really a blog post.
It's so long, though.
Yeah.
That article seems somehow appropriate.
Novella. Let's call it a novella.
Let's go with that.
He calls it brute force migration of existing SQL Server databases to SQL Azure.
And so brute force, of course, means manually moving each row by typing an insert statement.
That is correct. So what Roger did was he took AdventureWorks database, and this is the version that runs in SQL Server, and he manually typed every single statement into SQL Azure.
Yep.
Or perhaps...
And he put all those insert statements in this blog post. That's why it's so long.
Exactly. So what he did here is he documented his attempts to do it, and he outlines what he calls his brute force approach, which is actually the interesting bit, right? So he's got 11 steps to his brute force approach on how he migrated this database. And the greater gem here is that you can use this, obviously, on other databases other than AdventureWorks, which I'm not sure why you would want to do. Now, maybe Northwind. I would say Northwind, AdventureWorks, probably model 98% of all databases in the world.
Not model. I mean, those are the actual databases that most applications are built on.
I did a finance application once, and AdventureWorks was the actual schema for it.
Good. So this goes through like a whole bunch of stuff. What are all these steps? I haven't actually read through here yet, but what are the...
Yeah, how to provision the database, generate the DDL scripts. It actually addresses the clustering indices or indexes. I thought it was indices.
Yeah, I don't know. There's something weird, like the computer science term, you usually just put indexes, even though the actual word index,
indices,
you pluralize with indices.
I
bet it's one of those both things.
So he talks about using...
That's the important part.
Yeah, he uses BCP, and then he rebuilds the clustered indexes.
I see, okay.
And so this is the brute force
It's
approach.
not purely brute force.
Well, BCP is like...
At least the data is moved sort of together. But
I think BCP stands for brute copy procedure.
Procedure.
Yeah.
It's definitely
or process.
And quite a detailed post. It's actually, I mean, he goes through.
Well, yeah,
what he did in sort of each
this
step.
is almost Windows Azure Storage blog length, almost.
Hey, we've got a Windows Azure Storage blog post to talk about today, and it's short, so I don't want to hear
it. Yeah.
But yeah,
Brad must not have written that one.
This is a novella.
Okay, so here we go. Cloud computing is the next one. This is a little event happened.
Small little event called TechEd.
Tiny little event called TechEd. It was actually in New Zealand and Australia, and depending on which country you're from, you can claim that one is the state of the other, which generally gets the other guy pretty riled
I'm
up.
pretty sure they're the same place.
Yeah, I've heard. They both have kangaroos, I think.
Yeah, definitely.
So it must be the same place.
And Lord of the Rings.
Yes.
So
they have some videos. Now, not all of them are here yet. They're still apparently encoding them.
Okay.
And we have links here for at least for the Australia sessions. I assume you can also find the New Zealand ones as well. You're going to want to look at
They've been translated.
Yeah. They have subtitles on these.
Yeah.
They have Cloud Computing Online Services is the actual track. And in that track, you'll find things like the App Fabric talks. You'll find Dallas talks. I think there's some Windows Azure talks in there as well. SQL Azure, perhaps. I haven't seen too many, but there's I think it's
bound to be there.
That could be in the database track as well.
I see.
Depending on how they categorized them.
Right, but presumably, all the videos are up for TechEd or are in the process.
Well,
of being put
TechEd,
out.
yeah, TechEd is already the TechEd North America, the one in New Orleans.
No, I meant, but even these ones. So if they're in some other track, you can probably just sort of click over to them. Was my point. It's not just the cloud ones, but anyway, presumably good content there. I don't know. I wasn't there. I didn't see these talks, so who knows? Maybe they're terrible.
I think they're going to be awesome.
The way that I'm going to find out if these talks are good is I'm going to ask our viewers to go check them out and tell us if they were any good. So that's your homework assignment, people. Please do that. Okay, last piece of news, I think, is over on the Windows Azure Storage blog. And it's a short post. This is like the whole thing. I don't want to hear any complaints about, no, that's it. You're already off it. Right. This is about some fixes to the storage client library in the current Windows Azure SDK. So
it's a hot fix.
It's a hot fix.
That's smoking.
And it fixes two different issues. One is this weird kind of null reference exception that you can get. I don't quite understand where you get that one, but if you're seeing this exception, hey, good, we've got a fix for you. And the second one is basically just a missing piece of functionality in storage client library where the MD5 header was not properly sent on block blob uploads, I think is the thing. So if you set it to sort of, if you put that MD5 header in there so that would get sent to the server and verify that your data wasn't corrupted in transit, guess what? That wasn't actually working in the storage client library. It wasn't actually sending the header. So I don't think you got any errors, but you weren't getting that that sanity check that the data was getting there intact that you get with the MD5 header. So that's also fixed in this release. So I think that the way you get this is you go download the SDK again. And if you go to the SDK page now, it's sort of Windows Azure SDK. It's the June release, but as you go down, it's actually the refresh.
Refreshed on September 1st.
Right. And so in there is the new storage client DLL, and that's what you need. So you just need to go download the SDK again. Everyone who goes and downloads the SDK for the first time just sort of gets it. There's no additional thing you got to go do because it's there.
Awesome.
So that's it. So a couple fixes there.
All right. Well, let's move on to the feature this week, which is really around deploying and managing your applications in Windows Azure. So upgrading them.
Yep.
How do you keep your service running?
Yep.
Probably to start that conversation, let's talk about the ways that you get your service running, first of all.
We're just going to leave our notes behind our heads this whole time?
Sure.
All right.
This is our punch list of things to possibly talk about.
So, right. So talk about deployment first, sort of just how do you get the thing up and running, and then sort of where do you go from there. And basically, we've talked about some of the sort of mechanics of how you get the, like, hey, you can deploy from Visual Studio or you can go to the Windows Azure portal. I think there's an important difference to talk about between sort of deploying straight to production versus deploying to staging and sort of swapping in. And it kind of comes into play as we talk about the different update methods. They're also the same sort of thing. You can either kind of deploy over what you're doing kind of in place, or you can deploy to staging and kind of swap in. The mechanics of that, I think, are actually, like, the under the hood, what happens is something that I'm not sure everybody gets. Let's talk about the swap first, because I think that one's the less intuitive, but also really simple once you kind of heard it kind of thing. And if you do a swap, what that means, the reason we call it VIP swap, and you'll sort of hear that term, I think we're actually going to try to phase that term out, because VIP is sort of it means virtual IP address, and so it's sort of the public interface. It's the IP address that your users of your application reach when they go to it. And so the swap is actually, it's literally just swapping what's behind that VIP. And so if you have two different versions, one deployed to staging, one to production, they both have their own VIPs. There are load balancers that manage that. So a connection comes into that VIP and it goes, oh, that's this set of machines. We'll send it to version 1. Or a connection comes to the other VIP. They'll say, okay, we'll send it to version 2. VIP swap just takes those two virtual IP addresses and reverses them so that the original one now goes to the new version, and vice versa. And so when you do this in the portal and whatever, you'll see sort of a staging slot and a production slot. You'll hit this little button, and it would actually be really cool if they just sort of like went like this and moved. But it just sort of refreshes, and when you see it, you'll see that they've reversed. They're on different sides. The DNS is sort of reversed, so now my foo.cloudapp.net goes to the new version, while that staging URL I had now goes to the old version. Really what's happening is that the load balancer is just changing which version it sends these requests to. So requests they used to go here, now they start going here.
Funny bit of trivia on that, actually. So for swaps, you can always upload something into staging and have nothing in production. And then you can do a VIP swap of staging to production.
To nothing.
To nothing.
Which sometimes we call a promote. Promote to production.
Right. But the reverse is not true. Like, you can't have something running in production and do a VIP swap into staging if there was nothing in staging.
That is a good point.
So you do have to have, that's one caveat that you'll find, somebody's like, oh, I want to quickly take this offline.
Just take it back down.
Yeah, take it back down.
Don't see it.
Exactly.
Yeah.
You're kind of out of luck at that point. You have to delete the deployment or quickly upload something into staging and then do the swapping.
Swap that and then.
But really, I mean, it's a minor point, but it's a gotcha if you're not aware of that.
Yeah, I'd actually never thought about that before. So I guess it's either a proper swap or it's a promote, which really means it was staging, now it goes to production.
But no demote.
There's no demote.
Yeah, there's no demote.
You can't demote your application in Windows Azure. So that's how that works. So it's purely like a routing thing. I mean, it's like you've got both versions running. Right. We're now just going to start sending traffic to the other one. So it's fairly straightforward. It happens pretty quickly. I don't think we've published like a specific SLA around when. I think usually when we talk about it, to be safe, we kind of say like 10 seconds or so. I think in reality, it never takes more than a second or so it's really just the load balancer being reprogrammed to send to a different set of IP addresses. And so it's a very fast operation. And we'll get to sort of, I was going to bring something up that I think we'll get to later, sort of some of the limitations of this kind of approach.
When you can use it.
Let's first move over and talk about the in-place upgrade.
Right, which is the other method. We kind of talk about in the same breath of upgrade an application as two ways. So you have a version 1, let's say you have running in production. You upload version 2 into staging, and you do this VIP swap.
Yep.
That's one way of doing it. And then the second we call the in-place upgrade, which is you have something running in production, you do an in-place upgrade, and it literally does it on the running instances, does a rolling upgrade.
Right. So you never have two like full versions.
Right.
You have one that's sort of slowly being migrated.
And a lot of people ask, like, when do I use one? When do I use the other? And there seem to be some clear-cut cases where you use in-place versus VIP swap. And those you generally deal with things like, I have stateful or long-running instances on the back end. So let's suppose I have a worker role that's doing long-running encoding jobs for hours. I don't want to do a VIP swap because I've now switched the environments, those jobs can continue to run, but they're not an active part of the application, for instance. And so requests that, any communication that the production needed to have is now going to a set of different machines. It's not going to be able to route to those effectively. So the place where I see this used most is actually, I have some code I want to update in just one of my roles.
Yeah, that's one of the beautiful things about the in-place upgrade is you can actually pick just
I just want to upgrade my web roles or whatever it is. You can actually do that, and it'll do this rolling upgrade. And the part of that a lot of people need to understand is the rolling upgrades, and this is true for when we patch our OS, when we do other things. The rolling upgrade is really affected by your upgrade domains, and the upgrade domains is something that you have control over. I think by default, I think it was 5. I think we have that. Might be. Still.
I don't know what the default is. Yeah,
if you don't do anything in your
but it's a reasonable default. I mean, if you want to, you can just sort of leave.
It's not a crazy thing. So if you take a look, I think it's 5. But if you look at, I think it's the service definition. In there's a tag that says like upgrade domains or something like that. You can set that to some value, and what we'll try to do is we'll try to take slices of your application. We're going to divide how many instances by that number. Right. Obviously, if you have more upgrade domains than instances, that's not going to work. But, in theory, if you had 100 instances and you said 10 upgrade domains, we'd take down 10 instances at a time, and we'd go through the upgrade with each one of those.
And so what we actually do, we take 10 down, like this ordering is actually important. We take 10 of them offline.
Yep.
We deploy the new code
So you
update.
have 90 running, 10 down.
Right. Then we deploy the new version. Now those 10 are running the new version. We put them back online.
Yep.
Right. And then immediately take down the next 10. So again, you have 90 running. So basically, through this whole operation, you're at n minus 1 over n, with that being the upgrade domain. Okay. Anyway, that math formula useless. But the point is, we take one set down, one upgrade domain down, do that update, then bring it back in and do that over and over again. That means you never have to deploy more. You never have more than your 100 running to begin with, right? Well, in the VIP swap, you've got a whole duplicate. If you had 100 instances, now you've spun up 100 more, and then you've swapped them. Right. You've had 200 running this whole time, and then you've shut the old one down. In-place upgrade, you're never going to have more than 100 because all we're doing is taking some down and then bringing them back up with the new version. And of course, we won't touch the ones that aren't part of that. I mean, that's just for that role that we're updating. You can update all roles. You can
update all of them, but if you typically you would just use VIP swap if you're going to do that.
So this takes longer, right? Because the VIP swap the overall time isn't actually, it is longer to do this. But in the VIP swap, you've got the time to spin up sort of the new instance, but then the swap is very quick. Okay, I'm not going to say instantaneous because it actually gets to a point we want to make later. But it's very fast. If you're doing the in-place upgrade, it's kind of slow. If you have 10 update domains, you're taking 10 times. You're taking some instances offline, deploying new bits to them, and bringing them back, and doing that over and over again. So it actually takes quite a bit of time to work its way through. But everything's running the whole time. You've got just a little bit of reduced capacity because some are offline while they're being updated. And it happens in place, which means you don't have to actually run a whole bunch of other ones. So some of our biggest customers who are using a whole bunch of instances use the in-place upgrade just to avoid having to spin up. Really, there's almost a capacity problem with some of the large customers. Could we spin up a duplicate version of them all? Are there enough machines that are in the same pool with them, with the same load balancer, so that we could actually do the VIP swap? And so a lot of people use an in-place upgrade to avoid that issue.
The other part is, since you have control of the upgrade domains, right? You can set it to 2.
Yep.
And if you had 100 instances, it just means you're going to be reduced. Half your capacity is going to be gone. Your capacity to serve your users. If that's okay, I mean, go for it.
Yep.
But at the same token, if you decided with 100 instances you wanted 100 upgrade domains, it's going to take quite a while to upgrade your app because we're going to serially bring down every single instance, do the upgrade. So that actual deployment would take comparatively much longer than 50 at a time.
Right, yeah. Something like that. Yep, so you do have to think
this is a trade-off
and be careful. Let's talk about some limitations that are actually, I think, common to both. They're slightly different, but let's talk about limitations of these upgrade options. One that may or may not be obvious, let's talk about endpoints. Because if you think about what's happening here, like with the VIP swap and whatever, there's sort of this, I'm taking port 80 that was getting sent over here, and now I'm sending port 80 over to this other set of machines. And there's this question of what would you do if the endpoints changed? If like now you have port 80 and 443, and I don't know which in the old version I only had one of those, in the new version I have those. It's actually an interesting kind of weird thing. So just by way of explanation of it, it's a non-trivial thing to support, doing this kind of arbitrary, some ports were here, some ports are now over here. Yeah. And it's a different number of ports and they go to different places. It's a little bit weird. And so it's a limitation of VIP swap that you can't have a different set of endpoints, that you've got to have the same set of endpoints from in the old version and the new version. You also need to have the same number of roles.
Same roles, yeah.
Yeah, the same roles. And I guess that's true, right? They have to be the same named sort of roles and whatever, not just the same number of roles. So if you're changing the roles that you have or the endpoints that you expose, you can't use a VIP swap. You also can't use an in-place upgrade. And so both have the same set. So as long as you're upgrading equivalent things, basically, right, to the same roles, same endpoints, you can use either of these options. If you're doing something different, like adding another port, you are kind of out of luck with these options, which is what brings us, I think, to the third thing we want to talk about, which we talked about on a show, but I think we talked about it a little briefly. And this show is all about the options you have for upgrading. I think it's worth sort of revisiting this, which is basically to use DNS to let you kind of avoid these limitations of upgrades that you're allowed to do. So the way this works is you get a DNS entry, you buy your own domain, smarks.com, for example, and what do you have? Dunry.com, right? Dunry.com, and you put your application behind foo.dunry.com, myapp.dunry.com. It's a CNAME record. It points to an application you've got running in Windows Azure. Now when you want to deploy a different version of that application that has different roles, different endpoints,
completely different,
just could be anything else, right? Yeah. What you need to do is just deploy a completely fresh version of that. So not to the same deployment, whatever. Just grab a brand new myapp5.cloudapp.net, deploy it, and now just change the DNS record. So now foo.dunry.com, what did I say, myapp.dunry.com points to that new one instead of the old one. So users who type in, myapp.dunry.com now start migrating over from that old one over to the new one. They don't see a difference. There's no continuity issue for them.
This is like DNS as a layer of indirection here.
Basically, exactly that, right? So where VIP was sort of the layer of indirection in VIP swap, where you kind of send the traffic either way. Now we've moved it up a layer and said, no, it's a DNS. It's even above the VIP. Yep. You can start routing to it, a completely different place, a completely different DNS entry, a completely different application. This lets you avoid some of those gotchas around all this stuff. However, DNS is heavily cached at multiple layers.
Right.
It's cached on a user's local machine. It's cached at a bunch of DNS servers in between. It has a time to live that you set and then is obeyed to various extents at different parts of the system.
Right.
Basically, what I'm saying is there's going to be lag. You're going to change this CNAME record. You're going to immediately go in your browser and refresh and see nothing. And then after, I don't know, depending on the TTL you set, maybe an hour, maybe less, maybe more, you're going to see, oh great, I'm hitting the new version, things are good. Don't stop then. Wait. I'd give it a day to be safe. Make sure that everything is sort of moved over, that all the users around the world who are hitting different DNS servers are all resolving to the new entry. Now it's finally safe to take down that other one. Yeah. So I would say if you're going to use this DNS method, be prepared for sort of this lengthy amount of time where you're going to keep both running just to be safe. And you might have users hitting the old one and most hitting the new one. Yep. For some time. So
let's just do a quick recap. I mean, the purpose of all this is for zero downtime. I mean, obviously you can delete a deployment and just throw up a new one.
I forgot to mention that one. I really wanted to mention that. Which you could just take the thing. You can have downtime. You can just take the thing down.
If downtime's an option, go delete the deployment, upload your new version, done.
You got to do that.
There's a challenge with that, which is, well, there's an unintended or intended consequence, which we can talk about a little bit more. But let's first recap. No downtime, what you do is, if you're not changing your service definition at all, like same role, same everything, same endpoints, same config settings, same certificates, you can do an in-place upgrade. if you change the number of roles, or if you change I think it's your endpoints, and definitely your external endpoints. I don't know about internals, but
I think internal is okay.
So it might be okay. Wouldn't count on it. But if you change your endpoints or you change your roles, you can do, if you don't do those, you can do VIP swap. So you can change config settings, you can change those things, and bam, you can just still do a VIP swap. Now, if you change the endpoints or you change the number of roles, you've changed your application, you decide to add port 443 or whatever it is, you should use the DNS approach for zero downtime, which is spin up an additional hosted service, map the CNAME, wait a day, then finally tear down the old service. Okay, perfect. Now we come to the couple caveats with these things, right? And we see this sometimes because folks have requirements where IP addresses are whitelisted. That kind of thing. So, your application is running in our cloud. It has a VIP address. That VIP address is whatever it is your partner sees, and they only allow that VIP address to contact their service or whatever it is. So, you have this issue where the VIP address can change. And in fact, we are pretty explicit. We say, look, you can't guarantee that the VIP address will never change, so therefore use CNAMEs.
Right. And CNAMEs map directly to the sort of the text, the DNS entry of something.cloudapp.net instead of the IP address.
Right. So there's two records, right? There's an A record, which is, let give you an example, like smarks.com, A record could point to the VIP IP address.
Right.
Because that's a two-level domain name, it could resolve to an actual IP address. Then the layer on top of that, you would typically put a CNAME www resolve to smarks.com, which would then cascade down, and you would have this three-level domain name and reference, right? So for some of our partners, it's important either to have a two-level domain name, so they need an A record, CNAMEs don't support that, or they have a whitelist issue where they have to have a stable IP address for partner reasons, whatever it is. So here's the caveats. If you do an in-place upgrade, most of the time you're going to be fine. If you do a VIP swap, most of the time you're going to be fine. If you delete a deployment, guaranteed you're going to lose it.
Right. That VIP will be gone.
That VIP is toast.
You'll get a VIP again when you deploy again. I suppose it's possible it'll be the same VIP, but it's
very unlikely.
It's like winning the lottery to get the same one. I think it might be slightly better than that, but
I've never seen it happen.
It's something like that, right? You'll get a brand new VIP,
And so the DNS redirection that we were talking about, where you host another service,
definitely different VIP.
Definitely different,
because you have both of them running at the same time. The old one has the VIP it always had. The new one's guaranteed to have a different VIP, right? So you will lose that IP address if you do the DNS thing, or if you delete the deployment, the production deployment, and then do something.
If you only use in-place upgrades and only use VIP swaps.
VIP swaps, not promotes, but actual swaps where you've kept something running in production.
Then it's unlikely, but not impossible, that you would keep your VIP. And in fact, we would typically recommend folks, like, you can't count on it. Like, we could switch your VIP at any time. In practice, it might be fine for long periods of time if you keep this.
Ryan and I had this conversation before the show about how are we going to talk about this, because in some sense I hate saying anything other than the VIP is not guaranteed to stay the same. It might change at any time, and I want to just stop there, because that's really, if you're building a reliable service that needs to be 24/7, always on, high availability, that's where it stops. You have to go, okay, the VIP is not guaranteed to be the same. I'm only going to rely on that named DNS entry, something.cloudapp.net, and any CNAMEs you put sort of on top of that. But that sort of doesn't tell the whole story, which is that in the way things are implemented today and the way things have been going, most of the time you'll see that you keep the same VIP here. And so if that's important to you, if you want to maximize the chances of keeping the same VIP, maybe that's a good way to say it, make sure that something is continually running in production, and that you're always swapping into that or in place upgrading on that. And then you'll probably be okay. Okay, but don't call us the one day that your VIP changes unexpectedly, because we warned you. And
have a backup plan in place for those whitelist partners and things like that. For one day you're going to have to delete a deployment. Like there's something going to change. You're going to decide to change your app, add a new role. You're going to do your zero downtime.
You won't have a choice
You won't have a choice. You're going to lose that VIP address. You need to be able to know that that's going to happen. Talk to your partners, let them know, hey, VIP was this, it's going to be this.
Right.
So that's basically what it is.
Yeah, so that's that's most of what we wanted to cover. I guess really briefly, mostly as a lead into the tip of the week, I want to mention that in all of these scenarios, there was some period of time, in some cases longer than others, where two different versions of your application were running at the same time. Okay, so in the VIP swap, you had production and staging both running. You swapped them, and briefly during the changeover, some users were seeing the new one and some were seeing the old one.
Right.
But pretty briefly. That's a pretty fast operation. In the in-place upgrade, we had this, I take 10 down, 90 are still running, I bring it back up. For a while, there's actually a healthy mix of sort of the old version of the app and the new version of the app. Users hitting a website or worker roles running in the back, both are running for quite some time. In the DNS entry, I just said you should wait 24 hours before taking down the other one. Right. So you've got, again, a lengthy period of time where both are running. And I just wanted to call everyone's attention to the fact that you need to think about this as you design your app. One case that Ryan brought up, which I thought was really good, is queue messages. This is a case where it's so easy to get this wrong because you think, okay, well, the web UI changes a little bit. If both versions are running, some users see the old UI, no big deal.
Right.
But you've got this worker role in the back that's consuming queue messages. And if you've changed something about the way you generate those messages or the format of those messages or what's supposed to be done with them, you've got the old worker still just sort of stealing messages from sort of the new version.
And it's running in the
because they're
staging
racing,
environment.
right? They're both running. It doesn't matter where the worker's running.
Yeah.
It's hitting that same queue. It's reading these same messages. The different web roles are producing the same message.
I think people actually forget that because they're like, oh, it's two different environments. As
Right.
soon as they do the VIP swap, this role that was looking at storage account foo, queue messages is going to stop suddenly, and that's not true. The only thing that's changed is the VIP address and that
exactly
and that deployment. So you still have these worker roles now in staging, looking at your production queue messages, unless you quickly go in and tell it to knock it off, or you have some kill switch in there that tells it, unless my host name is this, don't do it. Right. So you will be stealing messages from your production system, and that could have very interesting impacts depending on what you were upgrading.
Interesting impact is a good way to say it. Right. So
bugs.
be very aware of this. And I think Ryan had the right idea, which is, you know what? If this is a challenge for you specifically around queue messages, make a new queue.
Yeah.
Just have the new version write to my queue version 2 and have the worker role consume that. And then you don't have this competition over the old worker role instances are looking at the old queue. The new worker role instances are looking at the new queue. Make sure you run the old ones long enough to sort of bleed off the rest of the messages, but you've got this case where you can do the swap. You've got a version match. The person producing the message and the person consuming the message are both looking at the same version because they're both using the same queue. And that way you don't have this confusion. There are lots of variants of this issue which we don't have time to get into, but in general, I think people should think about the fact that both versions are going to be running at the same time. Think about the backward compatibility and the forward compatibility around things like data, inter-role communication, queue messages, even things like web UI, where somebody might be on a new page and they might hit post, and when the post back happens, it hits the old version or something. There are lots of cases where this can come up, and think about always having that two-way sort of compatibility between versions and do that. So we've got one specific issue that comes up as you do this about sort of version-to-version upgrading.
Exactly.
That brings us to our favorite time in the show, the tip of the week. We need an intro to the tip of the week.
Well, we've been talking so much about VIPs, and you know, I think that you know, as the ambassador of the cloud, Steve is a VIP himself.
I see.
So you know, I'm like a mini VIP. So I'd like to see Bob take it in that direction with super VIP and mini VIP.
I am not your puppet anymore.
Mini VIP with me.
Mini VIP.
I'm scared of this one, but this is the feeling I have sort of leading in every tip of the week, so I guess it's okay. All right, well, with that, here's your tip of the week.
Tip of the week.
Okay,
all right,
mini VIP. So here's the issue. Let's just lay it out here. ASP.NET cookies are encrypted
by default.
By default, that's true. Actually, this is optional. But by default, if you just do things, the way that sort of happens by default in ASP.NET, set things up sort of the normal way and whatever, you will get some
session and view state as well.
Encrypted cookies, right? Encrypted view state, encrypted session state.
Correct.
So when users log in, they'll get a cookie and it's encrypted and it says who they are. And that way when they do a post back to the server or something, you look at that cookie, decrypt it, and go, oh, right, it's Ryan, because that's the cookie that I wrote.
And they didn't mess with the view state. They didn't change the cookies in flight. There's all sorts of reasons.
And I know all that stuff because it's encrypted, right? And so encryption, good. We do something in Windows Azure. So I guess actually web farms are interesting with this sort of encryption. And this is an issue that people who use ASP.NET are probably familiar with, which is that if you've got a load balancer and a bunch of servers back there, you want to make sure that a cookie encrypted by one machine can get decrypted by another machine, because it's this load balancing problem. The cookie got written here, but now it's being consumed over here.
Right.
So you need them all to have the same key. So in a web farm, you usually put in application host.config, or in web.config, you put this machine key element that has some value in it. That's basically the key that's used for encryption and decryption. As long as that's on all your servers, everything will work fine. In Windows Azure, to make sure that people don't get tripped up by this, we put a machine key element in your application host.config when you do a deployment. So this will come back. So it's important. When you do a deployment, we generate a machine key element and we put it on all the instances of that deployment, and then we let you run. And that way everything sort of works and life is good. Now, suppose you're updating your application and you do a new deployment to staging.
Yep.
You've got your existing deployment in production. Well, guess what? Because it was a new deployment, we've generated a new machine key element, put it on all those instances. You go to staging, you test the heck out of it, everything works great. You do your VIP swap, all of your users are now logged out. Right? And this is actually the first time I heard about it, was somebody said, every time we do a VIP swap, all our users seem to be logged out all of a sudden. And the reason is because their cookies are not valid anymore, because they can't be decrypted, because we have a new machine key that's the key for all this encryption. I believe it happens with an in-place upgrade as well, because I believe that that's part of the step. I'm not actually sure. In-place upgrade may be safe.
I'll have to test it. Oh, I'm not sure either.
I should have thought that through and checked that before we got to this point of the show. I'll try to track that down. I'm actually not sure, because it's the same deployment.
Comment
yeah, we'll check into it. We'll have to loop back on that, but. Certainly for a VIP swap, and certainly for if you're doing the DNS entry, it's a completely new application. Both of those cases will generate a new machine key element that will invalidate anything that was stored with the old key.
Right.
And so the common effect is all your users are suddenly logged out because their cookies are invalid.
And their session state and view state.
So they've lost all that stuff.
Depending on if you might get a view state decryption error.
Absolutely, right. Somebody might fill out a form, hit the button, and then all of a sudden it says this is a bogus entry. So lots of things can go wrong there. Now, you can put a machine key element in web.config, and that will override whatever's in application host.config. And you own web.config. That's part of what you upload as your package. So you can put in your web.config a machine key element with some key that you've put together. And as you do new deployments or whatever, you just keep that the same, and you don't touch that. That will take care of this issue in that now everything will be using the same machine key. However, it means you've put this machine key element unencrypted in web.config, which I'm told by some of our security folks is not the greatest of ideas. And generally, what people recommend is if you're putting something like an encryption key in web.config, you want to encrypt that section of web.config.
Right.
And there are some methods basically with ASP.NET to do web.config encryption. However, none of them work very well in Windows Azure.
Well, let's just talk about that real briefly, right? The issue comes back again to the web farm scenario, which is when you go to use the built-in ASP.NET provider, it uses something called Disk Protection API, or DPAPI.
Yep.
So those generate machine local keys. You can even have a user context security local key. But it's the exact same problem. So if you went to go do that configuration encryption, it would encrypt it for the machine that you did it on.
Right.
And then that key would be, or that ciphertext would be completely unencryptable on every machine.
So like you encrypt on your laptop.
Yeah, and your laptop can do it, and then everything else fails.
None of the servers in Windows Azure.
So you have to have a shared key to do encryption. Now, there's various ways of doing it.
Just put that key in plain text in web.config.
Exactly. There you go.
Done.
So that comes back to the problem.
Chicken and egg. Like, how do you share this secret?
So we know how to do it, though. It turns out we can use certificates. Certificates, and we have a secure secret store that is visible by all the machines in your web farm in Windows Azure, and that is you go upload a certificate to the portal.
Yep.
And then you configure the provider within your web config to use a different protection API than the DPAPI or the disk protection API. And it turns out that this is like, you know, if you spend enough time looking at it, you could probably figure out how to do it, but it's kind of non-trivial. It's a little bit of work. So there was a guy, his name is Varun, awesome dude. He figured all this out for us, and he posted it up to Code Gallery.
Yep.
And it's called the aptly named PKCS12 Protected Configuration Provider, because PKCS12, as everyone knows, is something.
We shouldn't even bother saying it because everybody already knows exactly what that is.
It's protected thing. So he uploaded this to the Code Gallery, and he even has a documentation on here on how to use it.
Yep.
So that's even better. What you do, you download this DLL, put it as part of your package, you put a little bit of configuration in your web config. Locally, because now you have the certificate locally, you run the ASP.NET set reg something, and which goes in and it'll actually do the encryption,
encrypt it,
change your web config file. You'll take that package, upload it, and since your roles now in Windows Azure also have that certificate, bam, magic, just works.
Magic. All that, you explained it all exactly how it works.
Magic.
And then you said magic. But yep, that's basically it. So this is a pretty good solution to get around this thing if you want to avoid putting sort of that plain text key in your web.config.
Yep. Looks like
this
we
is the
have,
document, right?
yeah, this is the 11 steps. Apparently 11 is a
11
popular.
is the new 10.
11 is the new 10. So we have 11 simple steps to actually do this. And the tool is ASP.NET_REG-IIS, so it is. All right.
Okay, I think that's going to do it for this week. So let us know on Twitter. Send us a message to @CloudCoverShow. Tell us if those Tech Ed sessions we told you to watch are any good.
And let us know what you'd like to hear about next week as well, or
Absolutely.
the week after. And also, if you have any feedback or just some personal attacks that you'd like to direct towards Steve and I, you can always reach us at CloudCoverShow.
Yep, or send us a fax.
Yep.
All right, until next time, bye.
Bye.